Okay, there's lots of places we see pendulums in everyday life. Okay, so name a couple of them. We talked a little bit about them the other day, but what's a couple ways that we see pendulums in everyday life? In a clock. Yep, a grandfather clock. That's the most common, right, thing we see. What else? Yep, a swing. Right, anything that swings back and forth. Okay, even just things like my little hooks that hang from the ceiling, right? If I pull that back and let it swing, that becomes a simple pendulum. Right? It's anything that has back and forth type motion like that. Okay, but there's a few more characteristics that make it a pendulum rather than just an item in simple harmonic motion. So, to be considered a pendulum, or to have kind of the definition of a pendulum, it's got some sort of mass at the end of a lightweight cord. Okay, it has to be a lightweight cord because we have to assume that the cord has a mass that's negligible in comparison to the actual mass on the end of the object, right? We want the mass at the end of the cord to be significantly heavier than the cord itself. Otherwise, gravity will have more of an effect on the cord and less of an effect on the mass, right? Still the same effect, but the ratio will be different. So we want the cord itself to be pretty lightweight, but it's important that it doesn't stretch. Why would it be important that it doesn't stretch? There would be a spring constant. Yeah, what else? That's right. Would it have a consistent back and forth if our cord stretched? No, right? The beauty of a pendulum is that it's supposed to be super consistent, right? That the period is consistent. The frequency is consistent, right? It lulls you to sleep type things, right? That's what we're looking for in a pendulum. And if you've got a cord that stretches, then we've got inconsistencies because we're bouncing and things like that. So it's important that it doesn't stretch and that its mass of the cord itself is pretty negligible. We will start using a new variable L for length of the cord. It doesn't have to be a capital L. I usually write mine in cursive so it doesn't look like a 1 or whatever, but L is going to be length of the cord.
What's the difference between L and X?
For our like amplitude side of it or displacement side of it. Yep, the displacement side of it is just talking usually about springs, how far that spring has been displaced. But this talks about specifically the length of the cord itself. So it goes from the axis point to our mass. Yep, good question. All right, this is just a pendulum frequency and period type problem. So it says a pendulum is observed to complete 23 oscillations in 58 seconds. Determine the frequency and the period of the pendulum. Now, don't overthink this in terms of it needs an equation. We know what period and frequency mean, so it's just a simple division problem. That's it, right? If I want to look for frequency, I'm going to put oscillations over seconds. Now, let's talk about what an oscillation for a pendulum looks like. A pendulum oscillation is not just over and back, right? A pendulum oscillation has to be over, all the way back, and back to its starting point. Okay, so here, back to here is not a full oscillation. It's got to be over, and back, okay? Or if you were just talking about from a high point to a high point, right? Let's say our pendulum started out held right there, and here's its equilibrium point. If it started out held right there, a full oscillation would be over and back, okay? But it's got to cover all the way back to its starting point to be considered a full oscillation, okay? I maybe shouldn't even say back to its starting point because if it starts in the middle, it's not just there, right? But it's got to be a full scope of that. So if I'm looking at frequency, I'm going to take oscillations per second. So frequency would be 23 over 58, and we're going to reduce that fraction or do the math to get it reduced down into a decimal because I don't like fractions. 23 over 58 gives me a frequency of 0.397. And what's my units for frequency? I gave you kind of that shortcut unit. Okay, hertz. Okay, and then for period stands for time, right? Or seconds per oscillation, so 58 over 23. Okay, the other way you could do that, right, this gives me 2.52 seconds. I could also solve for frequency by just taking the reciprocal of that. I could solve for period by taking the reciprocal of frequency, right? 1 over 0.397 is going to give me the same answer because we know that period and frequency are reciprocals of one another. Okay, so either way you solve for that is fine. But don't overthink these types of questions, right? We know that frequency is oscillations per second. We know that period is seconds per oscillation. So we don't have to have necessarily a separate equation that goes with that. Okay. All right. Here is now the equations for period and frequency when we aren't given information about oscillations and time. Okay. These look very similar to the other equations we got for period and frequency, don't they? Except we've replaced our spring constant and our mass for what two components? Length and the acceleration due to gravity. Yep. So these equations both should be put on your equation sheet, and I would label them as pendulum equations. So you remember that these are specifically for pendulums. The only caveat here is that as long as the cord is considered massless and the amplitude is small, I'll talk about what that means. The period has no dependency on the mass that's at the end of the bob. That's what it's called, a pendulum bob. Okay, as long as that cord is massless or has a negligible mass and the amplitude is small. So when we talk about amplitude of a pendulum, we're talking about if this is my equilibrium point, right, where it hangs in the middle. Amplitude is the angle from which you are releasing it. Okay, the angle from which you're releasing it. So we're going to do a lab with pendulums, and you'll kind of find out what your maximum amplitude is. Because if you start your pendulum too high, gravity will catch that object and pull it down rather than let it flow in its natural curved point. Does that make sense? Like if I've got something that is being pulled up, gravity will kind of drop it until the string catches it, and then it will flow. So you've got to keep your amplitude relatively low so that it stays in that curved path a little bit longer. I don't know if I've got my cord up here to show an example, but our amplitude's got to stay, for sure under, 45 degrees or 90 degrees for sure, but really 30 to 35, 40 degrees is kind of your sweet spot there. But kind of depends on the mass with that as well. All right, so let's try one. Very simple, all right? We're just plugging it into that equation. That's really it, okay? A pendulum with a 0.45 kilogram mass on the end of a 1.4 meter long cord has what frequency, right? Well, what did we just say about the mass on the end? It really doesn't affect our problem, okay? So don't get thrown off. They're like, I'm given a mass, but I don't need it. That's true. You just don't need it, okay? If I'm trying to find our frequency, that's my question mark. I've got a 1.4 meter long cord. Now, you're never going to have to cut that in half, right? Never cut that in half because that's the length of the cord, right? We don't care about the fact that it's from the axes or whatever. That doesn't matter, okay? So our length is 1.4. You can keep it as a capital L. It's just a habit of mine to write it in cursive. It's not the end of the world either way. And so I'm going to look at my equation sheet here to solve for frequency of a pendulum. Frequency equals 1 over 2 pi times square root of G over L. So frequency equals 1 over 2 pi square root of, what's G? 9.8. You don't have to include the negative here. Okay. And my length is 1.4. So again, we've got to be careful here because 2 pi is in the denominator. So just make sure we're doing either parentheses there or divide by 2, divide by pi. That's what I had on that one.
Will you walk through
Like the algebra for that?
Yeah, I did it like I did, and I divided by 1.47 because we have a 7, and then do 1 divided by parentheses 2 pi, so that, and then multiply both of them. I just feel like that's very like, back and forth. Like, is there an easier way?
Oh,
to do it?
Okay, so you did this as one thing.
Yeah.
Okay. So I just keep everything in my calculator. But you would have to you did 1 over 2 pi. What'd you get when you got that? Like, what number did you get?
15915.
Oops.
I got the same answer.
Oh, you did, but in my calculator. Okay, I got you. I'm saying. Okay, so I work inside out like that. I start with 9.8 divided by 1.4, second square root of second answer. That gives me 2.64. Okay, within this, the solution of that radical is 2.64. Like square root of 7 is 2.64. Okay, from there, I just go divide by 2, divide by pi. Because I don't want to use parentheses. Right? It's the same as doing divide by 2 pi, but I don't like to use parentheses. So I will just go, once I get this solution, I go divide by 2, divide by pi in my calculator. Yeah. Because I don't like to retype things in. So if I can use the answer anytime, I will. Right? I don't want to type things back in. It will make it a little more exact. Okay, all we're doing now is looking for the length of the chord. So now this time we're given the period and we're solving for the length. So which means we're looking for a variable that's inside the radical. That's going to mean a little bit different algebra here that we are going to have to look at. Oops. So period is 0.98. Sometimes we have issues if it doesn't say period specifically, but we have to remember that seconds tells us it's period, right? Without that label, sometimes people mix that up. So I'm going to start with t equals 2 pi square root of L over G, I think is the equation for that. Okay. And I'm solving for L. I guess I should just use a capital since that's what I gave you. I don't know why I don't do that, but it's just what I'm used to. 2 pi square root of L over 9.8. So again, here I'm moving 2 pi to the other side. So I'm going to be careful about either using parentheses when I move it over, or when I do it, I go divide by 2, divide by pi. And when I moved that over, I got 0.156. I'm going to round it there, but I'm going to not do anything in my calculator. I'm going to use that. Square root of L over 9.8. So what do I need to do to both sides there? Square. So in my calculator, all I'm doing is hitting the square button, and it's automatically going to take my answer. And then I need to get 9.8 moved over, so I'll multiply that over, and I get a length of 0.238 meters.